and we're basically taking the DMBOK, and I wanted to see where Veronica's DMBOK is.
Oh,
But just to warn people that this 4-day course is not a easy sit back and relax. There's lots of information, lots of consumption, and Veronica always scares everybody with this big book. And
yeah.
and what we've seen is that lots of Damer chapters actually have they set up uh, a working group, and in some cases they do it once a week. Some cases they do it one chapter, one knowledge area a month. Now, if you do 12 knowledge areas, that's a year. You've basically forgotten everything in your first year. So, and even with the 12 weeks, one can start forgetting. So I find it a difficult course, quite an intense course. So please be prepared. Veronica uses that term boot camp, where you're going to be chucked in the middle. Everything's going to be coming at you, 4 days of intense information, and you just need to be careful of that. Make sure you are prepared. So, for example, if you're picking up meetings halfway through, it's going to be very hard to hold on to. And I know Veronica gets all excited when you go for a meeting.
100%. It's you have to be dedicated to it. It really is a lot of information, but it means that we've got through all of that information, the entire DMBOK in 4 days. So you know the basic points, you know where to find what you need, and we train you into the best practice of how to tackle this exam with success.
Excellent. And I'm sure that Carolyn and Ross and all the other trainers will agree. Taking people through a 4-day course where they listen most of the times, that is not easy. But it is possible. We then take you through a set of quizzes and practice exams, and you've got 5 weeks to continually to do the practice exams. So, and we'll walk with you the whole way. So please don't think into the course training, have a nice life, see you some other time. We've got a 5-week exam training process, and you can get through it, and we'll support you along the journey. Okay. All right. So I'd like to start, and happy that you asked questions. I actually would prefer this time that we do ask lots of questions. This was a definition on abstraction. So we've gone through various almost representations of abstraction from the beginning. We did the essential concepts on abstraction. Then we did abstraction for details or specification. Then now we're doing abstractions for presentation. Okay. Now, please remember, this is not the abstract that you write on your thesis or that you do on an executive summary. It's not that. Okay. It's about how do we communicate concepts to the business people and how do they respond? Okay. So let's see what we can do. All right. So essential concepts in the beginning. Then specification, that was using the Zachman ontology with all the different cells and then breaking it down by audience. So almost starting at the executive, that has the subject area model. Then we go down to management that has concepts, and then we go to architecture that has logical model. Then we go to engineer that has a physical model. And that was the process of taking you through these details and ensuring that we getting the right level of specification. So we do that abstraction. So we don't try to fully define the entire system in the beginning. You can't do that. You can't specify everything. Otherwise, you're back to waterfall model, right? Where you have to have everything defined up front. It doesn't allow for change. Now, what I'm going to take you through is a little bit on presentation or the levels of details. Okay. Just to answer you on that 10-day course, and maybe Paul or Karen can. What we have done, for example, we've actually tried to do this, and people then just say, "Shucks, I can't take off 2 weeks from my business. I can't. I've got work to do. I've got work to get back to." So we tried a 2-day. We actually did a 2-day for a while, and then people said that was even worse. We then went to a 4-day and a 5-day. We've tried weekends. We keep on batting around, but we come back to the 4-day course and the 5-day. Okay, so coming down to presentation, let's talk about presentation. And I hope you don't mind. And I'd also love for Carolyn to contribute, is about starting with a definition of presentation and abstraction. And what's important is the Dama Dictionary defines these 3 definitions. Abstraction at the horizontal level, okay? And that's the process of partitioning a model into smaller subparts for presentation. What you don't want on a data model is a page that's got 400 different little blocks and lines and stuff like that. That kills most people. And they look at this thing and they say, oh, shucks. Now, I even remember the day that Steve Hoberman said, here is the SAP conceptual model, not the logical model, the conceptual model. And the page was almost black with all the ink. Okay, there was no white space there whatsoever. So we can't do that. We can't try to put everything in. So we've got to break it up. And I'll show you how to do that. The next one is abstraction for vertical. So now we're coming down, and now we're going down on the details, not the subparts or the sub areas or the subject areas, but we're going down on the details, and we're going from higher level entities and relationships to more detailed, more information, and we can go backwards and forwards. Remember, so if we reverse engineering, we start at the database, we then re-engineer the physical model. From the physical, we build a logical. From the logical, we build a conceptual. From the conceptual, we'll build a subject area model. Okay. And there's even another area that people refer to, and they call it middle out. And I'll show you middle out as well in terms of working with the conceptual model and subject areas and going middle out and then finding your different way around. So we've got horizontal abstraction, we've got vertical abstraction in terms of going down to almost the database level, from the concept to the database. And then we've got this last term, which a DMBOK defines as to say, it's common to use the term conceptual model to mean a high-level simplified data model, but that is a question of abstraction for presentation. Abstraction for presentation, meaning when I want to communicate with the business, I need to simplify the concepts, simplify the lines, simplify all the information so that they can consume it and respond and argue with it. Okay. So it is this thing of a picture says 1,000 words, but if the picture is got too much information, then we have the situation is less is better than more, and we just confuse the people. Okay. Then I got the definition from ChatGPT. I battled a bit with Google. It just kept on telling me that it's about writing a summary for executives or writing an abstract for research papers. And I went to ChatGPT and it's basically said, abstraction is a general concept. Interestingly enough, it's used in many contexts, and this is the important thing that I hope you get from this 4-week presentation. We have to say, when we're talking about abstraction, we're talking about this type of abstraction. Are we talking about abstraction for presentation, abstraction for specification, abstraction for common attributes and subtyping? Those are the different contexts that we need to talk about. Now, in this presentation, abstraction makes complex ideas easier to understand by focusing on essential elements. Okay, so we have to reduce the noise and the clutter and give them the essential elements. And this can involve removing irrelevant details, like, for example, the attributes, the keys, the indexes. Business people don't need to understand all of that initially to get an understanding and agreement of the conceptual data model. And then it's also summarizing a complex idea into a more straightforward concept. Okay. Are there any questions here? I'm gonna try and take it slowly and allow you to discuss and ask questions as we go, because if we go too quickly, then I lose you and you may not understand. So let's ask if anyone's got any questions. If not, then I'll ask you if you've understood. No questions. Okay. So let me ask my friends, Mr. Bolton, are you understanding these differences between horizontal abstraction and vertical and abstraction for presentation, why you would do it?
I would, Howard, thanks. I must say, I don't think I've seen an example of vertical yet, because on the modeling course, I saw the horizontal example, and it made lots of sense when you zoom in. But the vertical, I don't think I've seen that yet.
Okay, great. Okay, Gaucher, I see your hands up.
Good afternoon, everybody. Thanks, Howard. Just for me to understand, maybe I missed it. So the abstract for definition, I understand, and I maybe missed the other abstracts you've got for specification, and you have,
Yes.
I remember those things. Can you maybe just recap that, or maybe put it somewhere in a summary slide, or maybe I've missed it.
Yes, I will do that. So as soon as we finished here, I'll go back to the essential concepts and do that summary for you in terms of these are the different areas of abstraction, and then what will we talk about next week? I'll certainly do that. Okay, but it's basically we abstract for specification, meaning when a business analyst needs to get requirements from a business, this is the level of detail. Do not go into technical. When we go down from there to the next level in terms of we're going to executive, management, architect, engineer, it's all these different levels where we present the right amount of information for that audience to do their work and implement it or deliver the next model. That's what we call for presentation. We spoke about that for specification. We spoke about that last week. For today, I really want to focus on these different levels of a data model. And there's lots of discussions about, should we call it a conceptual data model? Is it a subject area model? Is it a data estate? It's those type of, what roles do the different models play and what message are you trying to communicate?
Thank you. Thank you.
Okay. All right. JG, any comments from your side?
Yeah, I mean, Howard, maybe just a question with respect to the construct of a data estate and then the subject area model, right?
Yeah.
So at what point is that, and are those both abstract elements, and there comes a time when horizontal blends to vertical because you're coming top down in a pyramid type construct, right? So I guess my question is, is the data estate an abstraction, or is that an artifact as a result of you being at a conceptual model? And the subject area mapping.
So yeah, and I'm going to give you some examples of this, JG. And what we like to do is when we talk to executives, we're talking about a list of data areas, or what we say is these list of data areas make up our data estate. These are all the most important business entities in the organization. And that's that metric of it should be between 12 and 20. And you use that data estate to build your data strategy, to build your touch points, your organizational touch points in terms of data ownership, data stewardship. They work on that, even down to a security level where we look at allocating responsibility of access to certain security people. And then metadata as well is based on the subject area. So and then even in a situation when you go to master data and you look at a domain, that tends to be a subject area. So does that sort of give you a clue as to what and why we talk about a subject area or a data estate?
So just playing it back, then it sounds like a subject area versus the different data estates that you know, the 20 odd concepts, you now get, you now blend those in a subject area map in order to I mean, I guess because that's where you would assign ownership and you would make sure security is covered, etc. So
an operating model, yeah.
Would you then so I mean, I guess I know of those concepts, but I can't figure out whether I've used horizontal or vertical abstraction to get to them. Or
Okay, All right, okay, so I'm going to come down to the next slide in terms of then giving you example of how and when we do horizontal and vertical abstraction. Yes, Ross.
Thanks, Howard. So just a question in this presentation idea. I mean, abstraction can get pretty, I guess, confusing. I mean, do we take like an employee entity or customer entity, and I mean, it would make sense to abstract all the way to like a party, right?
Okay, so let's get in there quickly. What we're saying here is that this is not the abstraction I'm referring to. What you're referring to is the abstraction of common attributes, common relationships, subtype, supertype type stuff, right? This is not for that. This is for presentation of information to the right audience. So that's where we come into these three abstractions, one for specification, one for presentation, and one for commonality or typing, right? Okay. And we're going to be doing the typing next week. But today, it's really about our ability to become more and more precise in our definition and more simple in our presentation to the people that need to agree what we're defining.
Okay, got it. Thanks.
Okay, cool. All right, so let's come down a bit. And I think, so the other thing I wanted to just make you aware of is what is the definition of a concept? Okay, so when we talk about a conceptual model and a concept, I think it's really important to just, some people call it critical business entities. So, and it's not critical business or critical data elements, please. Those are columns or attributes. We're now talking about the core business concept, core business entities. And what I found very important and very helpful here is to differentiate between what is a concept versus what is an idea. Now, an idea stands for a rough mental construct, while a concept is a refined notion developed from extensive analysis, extensive discussion around the definition of what do we mean by a customer. And if you remember some time back when we spoke, and we'll deal with this again in Business Glossary, we said, please get your business definitions right first, then look at building your conceptual model, your concept models with its relationships. But your first port of call is getting the definition right. Now, there's a big difference between a concept and idea. Typically, an idea is usually an individual effort. Someone comes up with a nice idea. JG, he's always got amazing ideas about data value realization. Fantastic. Have a nice life. Is everyone in agreement with it? That's a different story. On the other hand, a group is needed to establish a concept. The business departments must establish the concept and agree on it. It's not you, Mr. IT, data architect, data modeler, that says, here we got a party. Be careful of that, because you're then forcing this, and you're not developing it as a group agreement. You're creating your own idea, or you've got something from Oracle or wherever it is, and now you're saying this is the thing. So be careful of that situation. And then what is a basic concept or a critical business concept? And basic concepts is a foundation of expressive and receptive communication. These are the basic concepts that we're dealing with in our business, that everybody can recognize, from the CEO to the CEO, to the CDO, to the CIO. Everybody recognizes these concepts, and we must be in agreement with you. And then we keep saying, be careful to abstract too high, because you can cause some problems. Now, I will share with you that when you go into a master data model, in that case, you are actually looking for abstract patterns, because then that domain can deal with more entities and can deal with more information. But let's not get there. I don't want to jump on that too quickly. Now, when I go to ChatGPT and I say, please explain concept, it says concept is an idea or notion used to describe, explain, or evaluate an object or an action in terms of a business transaction or a business event. That's the concept. It is abstract thought that conveys an abstract meaning, usually expressed in words. concepts often used to describe theories, models, or to explain their relationships. Okay, so for example, we will say we are talking about customers. Okay, or we're talking about employees. Okay, that in itself is an abstract notion. The people are individual people. Yes, they play a role of employee, but the actual term is itself not a physical scenario. Okay, but it can be depending on how you level. Now, conceptual is describing something related to or based on a concept. It can refer to abstract concepts and physical objects representing those concepts. So that's when we start talking about instances and what can go in here and different areas like that. Okay. Now, let's go to the DMBOK. This is the enterprise data model. And I'm going to show you a little bit about this thing. Remember, the DMBOK describes a conceptual model, and then it describes that you can break the conceptual model into subject areas, and then you have a logical model that's done by subject area. Okay, and then you have an application logical model and physical data model done for each application. So your data architect is responsible for agreeing these top 3 levels. Okay, now this is where we can start applying the different approaches to abstraction. So the first abstraction, JG, is when you start at the model and you start laying out or breaking your model up into the different subject areas. Okay, and you should have no more than 12 to 20 of these subject areas. So what we're doing now is we can take one subject area at a time, get it defined, then go to the next one, then go to the next one. So now we're moving horizontally through the conceptual data model. Okay. The other approach that you could do is you could do a vertical abstraction. So can you see here, we go from concept down to these next levels here. We then go into a logical, and then we go and implement it in a physical data model. Okay. And okay, so yes, Paul, so you've seen how we take one area and drill down. Now this is, remember, if you guys remember when I said middle out. Middle out is when you start going along that horizontal abstraction. Okay, when you say, okay, I've got the subject area, but you know what? Sales is also, or sales is dependent on product. Okay, so that's a different subject area. So let me complete that so we have a more complete model that we need at a logical level. Okay, so again, just to pause here, can you see the difference between vertical, where you specifically going down to detail to almost look at what would this look like in a database, or if you reverse engineer, that's also quite helpful when you go from here, physical data model to logical to subject area, and you bring it together in the conceptual model. Okay. All right. Any questions on that horizontal versus vertical abstraction? Okay. All right. Let's go down another level. So this was a really good example that we have in our course notes. You can see the left-hand side with enterprise modeling levels. And you'll notice here that right to the side, if we were to take, let's take a horizontal level, we've got product design, commercial offering, and sales. Those are our 3 subject areas. And then we can go and drill down by subject area into the detail for this and build a conceptual model. And here we've got product group, product platform, product part. And it's helpful when we show it like this that we can see, product is also dependent on sales, or sales depends on the product. Okay, so it's very hard to build a commercial offering if you haven't got the product design defined. Okay, and this is the way that you would piecemeal this thing together. Get the product done, then look at commercial offering, then look at sales subject area. Okay, and then flesh out all of the concepts in the conceptual model, and then you can go down another level into what we refer to as the logical model. Okay, now let me give you an example of that. Can you see this is the horizontal partitioning that I was talking about? And we're sort of fencing off a part of the diagram. We look at that and then we move to the next part. We then also go down to, let me just get out of that. We go down to the vertical one. These are vertical levels. So can you see here, we're almost at a conceptual level. Then we're taking a small piece, the parcel of land, and then we're showing what is the data model related to that parcel of land. And then we can start adding attributes and then more physical data models. And so we go coming down and forcing out the detail. And of course, each time we're adding more objects, more elements to the data model. There's your depth, and then your horizontal is then partitioning it. One subject area at a time. JG, is that, and Paul, is that explaining how we move and how we go through the different data models? And of course, you may choose that I may be focusing on this subject area for now, and then I can extend to the next subject area and the next subject area, or I can go down to the physical model. So basically, vertical is like a drill down. That's from Hisham. Yes, you're drilling down in terms of detail, and that's exactly what you're doing in a pivot table. If you go from year, quarter, month, day, 100%, you're coming down into the detail of the data, and then you can roll back up again. So it's also a nice analogy, easy to understand the years, and then things get a little bit noisy when you go down across all the years, all the quarters, and then it gets really noisy. Okay.
So Howard, when you talk vertical and we're drilling down to the application, yes, automatically you might think of physical modeling at the bottom, right?
Yes,
do you stay
correct.
at a conceptual level when you're doing horizontal abstraction?
Yes, you go from one subject area to the next. Okay.
Just stay at
so you're
conceptual.
Going, okay. Yeah. So you're now trying to get all the horizontal right. Okay. And this may be important, for example, if you want to define the global scope of the enterprise data warehouse, that's the type of thing that you're going to do is let's go wide to understand what are all the elements, but then you go and implement. So you design globally and then implement locally.
Sure. Cool.
Yes, Carolyn. Sorry, you're on mute, Kara? You're on mute?
Sorry.
Sorry.
So that design locally, design globally, implement locally, is that reflected in terms of your conceptual, your subject area models and your logical models are at an enterprise level, whereas at the lowest level, your logical models and physical models are more at an application or project specific perspective?
Okay. Yeah,
okay.
let me try to explain that more. So what you do when you design globally, you'd go on the horizontal abstraction. Okay,
right.
So you're moving along here. So you've got your whole data estate defined. So you know where everything is. So if someone asks you, where's this? Oh, it's over there, but we're not dealing with that for now. So now what we would then go do is build locally is we would then choose an area, for example, product design, to come down into the warehouse and come all the way down to the transaction level and that data mart level. So that's when you pull down the detail, and then you're going to go conceptual, logical, physical. You're going down that's when you start doing vertical implementation. Trying to do one subject at a time, get it down, get it into the transactions, get a data mart built, and now we're happy.
Can I ask another question on that?
Sure.
So at the conceptual level, well, I understand that tends to be sort of the architectural view, which is your forward view. Whereas I understand your project perspective tend to be your sort of in transit state. Does that apply to this model as well? No.
No, not really.
Okay.
So when you build a model for an application, so remember what we're also doing here is we're moving away from data architect to data modeler. Data architect will build the enterprise model, and then here is where the data modeler kicks in. Now, this is when the business says, I need this application to provide and automate these business processes. Okay, and of course, there's nothing wrong with the data modeler building a conceptual model of the data required by the application. Okay, so they're not forced that they can only do a logical model, but if you've got a good enterprise data model supporting you, then you don't really need to do the conceptual model. You've sort of already got that from the enterprise, but you do have to build a logical data model.
Thank you.
Okay, and then what will happen is that the data modeler will be taking care of the logical data model and the physical model for that application or for the data product, the data mart. They would take care of that. Yes, Ross.
Sorry, when we've been talking a bit about good and quality and stuff like that, and I was just wondering in terms of these horizontal models and these high-level conceptual models, you know, if there's Hoberman's scorecard becomes you know, relevant and
Okay, so Hoberman's scorecard is relevant at every single model, every single level. Now, where you have to be careful is there's this sort of level of communication, right? So as you're rolling higher up, you're talking about things like scope and then communication, then basically communicating the requirements. So what I like to do is, let's say Caro does this, she does this quite often. She does a set of business requirements for her business users. And that would be written in Word or some business process models. Then it's okay, let's build the conceptual model. And what I like doing, and I'm actually going to get to that a little bit later, is one would take a marker or something in the Word document and highlight all of those concepts, the who's, the what's, the where's, the when's, highlighted in the Word document. Go and look at the conceptual model and then say, have you added any concept that was not in the business requirement? If you have, you are now out of the scope of the requirement. Okay, so Steve Hoberman's one, you actually got to come down past those 10 categories and actually see, how do I measure or manage the scope, the implementation, what's been done, and whether it adheres to what the business have asked for. And then there's good business definitions, and there's a layout of the model that you talk about. And you would typically get the business people, you would be talking to the business people to see, well, do you understand what this model says, and are you comfortable to read it and sign it off?
okay.
All right.
Okay.
Okay. Caro, I'm not sure if I answered your question. Are you comfortable with this drill down and details and?
Yeah, thank you.
Okay. All right. Fantastic. All right. Let's keep going. So this is horizontal drill down, vertical in terms of your depths. Now I'm actually in some cases going down to the data, and I really like this. One of the ways we do it, and Steve Hoberman suggests is, yeah, you can talk at a high level with the business, and then at some stage you may be getting a nasty feeling, for example, that this cardinality is not what do we have in our data. You may want to come down and drill down and actually see what that database looks like, but not to show the business at that point in time. You're just going to check to see whether that thing fits the rule of the database, of where the physical data is now. Okay. But let's now take a little bit of a step back. And I like these examples of saying, let's go through the process. First of all, I'm a business owner and I come to Caro, who's the business analyst, and I say, Caro, I want a house. Can you see this house? And you are the business analyst or the data architect. Can I have a house like this? You take a photograph and you say, okay, architect does a quick sketch to say, is this more in line with what you wanted? Okay, it's got a porch, it's got a fireplace, it's got some rooms, it's got a kitchen, fantastic. This is what I want. Okay, this is at a high level, we're in agreement with this scenario. Okay, then we go down to this situation where the architect spends a little bit more time. They've come out of the field. They've spent a bit of time. They've almost built a model. You know how the architects build those models? This is what it's going to look like. Are you comfortable with that? And you say, yes, I am comfortable. And then he takes that model and breaks it down into this scenario over here, which is, so this is our conceptual model. This becomes the logical model. And now we're seeing all the rooms, where the doors are, what is the walkways and different things that you've got, where you'd put the freezer and things like that. And then from there, you would go into a physical model, which is almost the electrician model for the electrician to be able to implement the lighting. Okay, so can you see how you're going from that level of detail? Users agree, fantastic. This level of detail, there's a lot more information now to see, well, how is this layout going to look like? How are we going to build these different rooms? How they're going to interlead, and then right down to the bottom, which is how does the electrician put all the wiring together? Okay, conceptual, logical, physical. Is that helping people understand the sort of level of detail that we're coming out? Now, let's do another one. Let's say you've got the technical implementation or the electronic implementation, but you've missed somewhere along the line, you missed the concepts. All you can show the business at this point in time is these lines over here. Now you've got to reverse engineer to logical and then rebuild the concepts to make sure you're in agreement with what the requirements are. Yes, Gushe.
So basically the third picture is maybe the one for the electrician. Then you can maybe have one for the plumber, as you said, and you can have one
Yes.
for the, so it could be
100%.
resolving different databases at the end.
Yes, yes.
Different databases forming the same data to get to the middle picture kind of thing. So it's all
100%.
abstraction of data then at the end of the day as well. Or
100%. So, yeah, so what you, and there's actually a CDMP question on that in terms of saying this layering, typically you can have one logical that supports many physicals, a JSON implementation, a relational implementation, a graph implementation, all the different physicals are sitting there, electrician, plumber, whatever it is, and you can implement it in different ways depending on your database management system that you choose that supports the requirement the best.
100%.
Okay. Now, another hand went up there, and yes, Ishan. JG.
Yeah, sorry, I didn't put my hand up, which is how. So I guess one of the challenges that I face is before you started this course, I always had abstraction as a level of resolution that you are looking to get a higher and higher level of representation. So it's that party model. I've always
Okay.
I've always
Right,
had the word abstraction linked
Right.
to the party model, but what I see you doing now is there's it's almost a drill up. There's a drill down and a roll up.
Yes.
Traversing these things, but you're using the word abstraction. That's, I guess, I wasn't expecting that. Maybe you can help.
Okay, but remember what I'm using. I'm actually using the word abstraction for presentation, not abstraction for genericism or subtype, supertype, common attributes, common associations, common relationships. Okay, so that's where I'm trying to be very clear here is abstraction can be used in many different concepts. We have to be clear about the concept that we're using that word in, otherwise we're going to confuse everybody.
Cool. Okay, thanks, Howard. So we are only talking about abstraction for presentation here.
100%. 100%. That's the core reason. The core reason for going through these different models is being able to present it and communicate with your audience at the appropriate level. Yeah. So, Carolyn, that's actually why I did this, why I started with abstraction, is Veronica said to me, you know what, the thing that killed her in the data modeling exam was all these questions about abstraction, and she wasn't sure what they were talking about because she had just looked at the Steve Hoberman book, and it was just about supertype, subtype, or generalization versus specification. And this was, and here we're talking about abstract for presentation, horizontal abstraction, vertical abstraction, and the different levels.
Yeah, also I was surprised when you said this was relevant for architecture. I was thinking, oh, okay, I'm going to get a lot more detail on modeling. So yeah, but it's great. It's great to get this perspective that you can apply this across different areas, not necessarily only one very small chapter.
Sorry, Howard, another question. No, Gushe, sorry. Sorry.
Thanks, Ross, but you can go ahead.
No, Gushai.
Oh,
Gushai, please, you
okay.
had your hand up first. Please continue.
Thank you very much. Just for my understanding, to bring it back to specification. So basically, if you want to bring the specification into this whole picture of yours, which I completely understand, so that might be the data sheet containing the information to create, for example, the plumbing for the plumbing. Is that kind of where the data specification?
Yeah. So let me. I'm actually.
Maybe you are.
I think I need.
Sorry, maybe I'm hitting the ball miss.
Yes. Okay. So let me quickly go. I'm going to jump to this in data architecture. Gushai, and I was going to come back to this, but I think it's important. So, for example, what I've been showing you is almost what we call this vertical abstraction. Can you see here? Subject area model, JG. Can you see list of items for the executive? Okay.
Howard?
High level. Yes.
Sorry, Howard. I'm still showing the. There we go. It just came through late.
All right.
There we go.
Sorry. Okay. So, Gushai, here is what the way that Zachman puts this whole framework together. This is what I mean by abstraction 4, specification, where you can go down subject area model, conceptual model, logical model, physical model, data definition, data dictionary. Okay. But what you have to be careful of is that conceptual model needs to link to your business process model, needs to link to your logistics, your workflow, your timing model, and your business plan.
Your operations.
So can you see how this thing is? Sorry, sir?
And your operations model, your operational model.
Yes. Oh, yes. Your operating model, your roles, your people, how they're making different decisions, your motivation, the rules, the business rules, all of these things link together. And this is why I like the ontology of Zachman.
Yeah.
When you look at TOGAF, it's more about the different processes that I need to create, but Zachman focuses on the core elements, the periodic table of models for enterprise architecture.
Yeah.
That's what Zachman focuses on. Whereas TOGAF focuses on the different areas and the different processes and going through the motions. And I like almost to have them both. So this would underpin TOGAF to say, am I producing all of these deliverables? The same way as the DMBOK has the deliverables, and you could be using it on EDM Council, you could be using it across all the different areas. I'm hoping that makes more sense.
Yes, so it's the deliverables
then what you
vertical, maybe like that.
Yes. And then can you see, if I start going down a level, can you see this is system logic, and it talks about inventory representation at the DB model. Okay, then it talks about a process representation. Then it talks about an organizational representation. Can you see how these things all work together? They're not operating in isolation.
Yes, I can see that. Makes sense, yeah. Now I think I get a better clarification on, but maybe I should less focus on the specification model and more on the presentation.
Yes. Okay, so let's go back to now. I'm presenting. That's what JG was, what we were talking about, and I'm presenting different levels of detail to get confirmation that I have understood what they need, and that does talk to specification. So when I say I understand the need, that's a specification element. So let's just go to 58 again. Okay, so these are the concepts. Then I drill down and I get a better definition and a better definition or more detail. And then each person understands what they need to understand. I remove the noise. So for example, the electrician does not need to know about the bathroom here and this one over here. The plumber needs to know that, but the electrician doesn't. So I must just give him a physical model of what he needs to implement. Okay, so that's the different levels of stripping the data in and out and going either horizontally or vertically down to the detail that you need, depending on who's going to be implementing what. Okay, then Veronica's asked me, and she pointed out in the DMBOK on data architecture in page 99, and I'm going to read this to you. And this is for you, Kara. It's also saying data architecture is fundamental to data management. That we know. Okay. But because most organizations have more data than any individual, that any one individual can understand, it's necessary to represent the data at different levels of abstraction so that it can be understood and managed and make decisions about it. So that's why we go up to the subject area, JG, is so that we can develop and allocate responsibilities. Who is the data owner? Who are the data stewards? Who's going to be responsible for the quality of all the data in this area? It also then goes to when you start building an enterprise data warehouse and you have to think globally, but implement locally. So you know that you're not going to be jumping over and leaving things out. So a lot of what we're doing here is making sure that people can comprehend what it is that you're talking about, but you may find it difficult to show them everything, especially at a logical model or even at a conceptual model, but you can show them that at a subject area model. And if you remember, I will also use this term MEES when I refer to the subject area model, which means mutually exclusive, collectively exhaustive. I have all of the core business concepts of the business. There are no holes, there are no gaps, but they don't overlap. That's the important. No overlap, no gaps. Nothing can fall through the cracks, and nothing can be confused about, oh, it should be done there or here. It's one place and one place only. Okay, JG, I'm hoping I haven't confused you, or are you following on? Are you hanging in there?
Yeah. So, I mean, is this following accurate? Is that you've used subject areas synonymously with they make up your data estate. So is that an accurate statement?
Yeah.
Is that your data estate is a Macy collection of your subject matter meta areas?
Yes.
Okay, cool.
JG, why I've done that, why I do that is that so many times the executives really don't know what I'm talking when I say subject area model. They really don't see it. Okay, and it doesn't matter how many times I use it, they just don't get it. So I try to say, this is your landscape, this is your estate, this is all the data you have in your organization, and they relate to that term better.
Cool, thanks, Howard, that's clear, thank you.
Okay. All right, so just going, we've got 5 minutes left. I just want to take you through this. So here's an example of a very high level data diagram. And I can see people, they start, there's so many times there's confusion around this term conceptual logical. So they take this type of approach. Here is a high level diagram of the house. It's either a photograph or something that looks like this. A high level data diagram looks like this. Okay. And this is also known as a subject area model, a data estate, or a data landscape. JJ, I'm hoping that is a much better example. Yes, sir. Hand up. Okay, great.
No. It was supposed to be thumbs up. Thanks, Howard.
Okay, great. Now we drill down and we're trying to get a little bit more detail in terms of that, and we're now trying to start getting the business to sign off our definitions and our business rules, and now we come into a high-level data model, which is the conceptual data model. But sometimes people are trying to avoid all of these different terms, and let's just say very high-level data model, high-level data model, and then a logical data model. So here, what's nice about this type of data model is you can see that the image, and now we've got house, porch, and bedroom. Okay, and we've got a very simplistic model with the definitions. Are we in agreement with that? That we've got the scope and we've defined it correctly, and then we go back to Ross's discussion of, is this an accurate reflection of the business requirements? Okay, then we go into a floor plan, which is the logical data model. Now we can start seeing we've got some attributes, for example, the different doors, the wash basin, all these different things. And then we go into a physical data model where we've got the wiring diagram. So we're coming down one step at a time, and we're talking and we're removing the detail, only the detail that's required for the people that have to use the model. So when I present to them, I don't want to present this diagram to the wiring guy, the electrician, okay? It's just like I've got too much information and I don't know where the cables need to go. Right. Okay, now I actually just want to take you back and just summarize a little bit. This is the way that the DMBOK presented it, and I have to admit I like this level of detail: subject, conceptual, and logical. That's the enterprise, and then we have the application, logical, and physical data models. That's what DMBOK version 1 said. And the common understanding of these different levels is conceptual. It's a high-level, enterprise-wide abstract model. Okay. Physical is how the data is stored in some database, some system. And then logical is, yes, sir.
It's not sharing again now.
Oh,
It is sharing. We've actually
okay.
experienced this during presentations sometimes. Some people struggle to see the presentation. Just if you can find Howard and just click on him in your Teams, it might pop up. Okay.
Refresh, thanks.
Yes.
All right, so what's interesting here is that as we're going up this level, we abstracting and we talking about the presentation, the important elements, and as we're going down, we're picking up more detail, but still please remember we've got this vertical abstraction, okay? And we're drilling down to just the detail within those areas, and then we can go wide to not go too far down it. So continue to remember vertical and horizontal abstraction and the different processes of it. And then I'd like you to go down, I'd like to bring you just down a different level in terms of what does a concept mean? Okay, these are the different levels, and it's an idea or a notion that we've developed together as a group. And then we have the conceptual process, which is the process of doing this abstraction and defining the relationships that we have. And then a logical data model, and this is what I found quite interesting, is logical is according to the rules of logic or formal argument, characterized by a capable or a clear sound reasoning. Now, unfortunately, all models are logical data models. We should have a clear reason behind what we do in all of the different models. So sometimes a logical data model is also a little bit confusing. The term doesn't always fit well and doesn't always make sense, but that's what our definition is there. Now, just coming back in terms of reviewing, what we're talking about is omitting versus hiding. So here we have reality. We then build a model or an abstract presentation of reality. And then when we go to presentation mode, then we hide certain details to present to the users that need to sign off and understand what it is that we're presenting them and what are we giving to them. And then I wanted to end off on this situation is, can you see that what we do, the process of doing the data modeling is, first of all, we'll talk to this business for scope. We'll get their user narratives or the user stories. From the user stories, we get the sentences or facts. These are the facts of what the business, how the business communicates. And then we take those facts and we highlight them with different pens, giving us our nouns and our verbs. And through this process, it's all about what people refer to as business fact modeling. We're modeling the facts about the business. Okay. And then when we get into this ER modeling and things like that, now we're talking about primary keys and column names and attributes and normalization and constraints and foreign keys. So this is the relational modeling. And then finally, it gets handed over to the DBA. They can denormalize it. They can add indexes. They can change some of the data types, and they can use partitioning and distribution. So there's these steps that we almost go through. Here's the first step where we communicate with the business about the facts in the business, the different nouns, the instances, the types and supertypes, the constraints that we have. And then we hand it over into this relational modeling where we resolve to, and we do denormalization, primary key, alternate key, resolution, column names, attributes, role names. and entity record. So can you see this process that we're actually following here? All of it should be logical. All of it should follow a set of rules. But in the beginning, we're there to model the facts of the business. Once we've modeled the facts of the business, really looking at the business requirement document, we can then go down to the relational modeling for relational database, and then we can go to physical modeling depending on where we need to be. Now, almost like to present it like this, where we say we've got the business data model that we created here. This is our business data model. And now we can build many different conceptual views to interact and engage with the business to get sign off to say, yes, we agree with your data model. And then when we go to inward facing, i.e. to the developers and the DBAs, now we present to them SQL code or DDLs that they can go and implement in their database. So we got to be careful, and there's lots of noise of logical versus physical versus conceptual. But at the end of the day, what we're really trying to do is make sure we've got all the facts from the business. We then do appropriate level of normalization, resolving, building keys, understanding relational tables, going through that process. And then the next one is physical modeling. And we then get to, this is the movement of this information. And then you've got to choose how you present the views of the model to the business. Okay. So sort of want to just stop here and try to see whether I've actually added some value to your understanding of abstraction for presentation, and the journey that we go through in adding the detail to the model so that we can communicate correctly to those that need to sign it off and those that need to implement. And each time we need a different level of model that presents it to the people that are going to have to do the work or sign the thing off. But let me pause there and see if there are any questions or anything that you'd like me to explain. Yes, Ross.
Yeah, thanks, Howard. So the one thing that occurred to me is that in terms of the analogy with the house architecture and stuff like that, what I found significant there is that there's a spatial representation. So the rooms need to relate to each other in a very well-defined way. Bathroom, kitchen, and then even the plumbing and stuff, it needs to all overlay, and you can't have your lights in certain positions because of plumbing. Whereas in our business data models, it seems to me that the relationships are obviously more significant than any kind of spatial presentation. I mean, you can draw these things well within reason, and obviously trying to keep clarity. But I mean, you can draw these things at any kind of spatial kind of layout, but
it's
I mean, I'm interested in the integrity. How do we make sure that the lower level diagram models are consistent and there aren't conflicts?
So
that's
you
what I'm
always
trying to grapple with.
Yeah, and I remember sharing with this, I think on the last time, Ross, remember there's two types of lineages. You've got the horizontal lineage and where the data moves, but you've also got a vertical lineage going from data dictionary to your physical data model, to your logical model, and that's element by element, right? It's attribute and entity in the physical model needs to link to your attribute and element in your logical model, and that needs to link to your business entity. Okay, there needs to be that traceability. The data model holds these things together, and you can go from a logical to a physical, and you can see the connection.
Yeah.
So that's the one thing. But I would also like to share with you that Steve Hoberman talks a lot about diagramming clarity. And there's some really nice papers on how to structure your logical model and getting the right clarity of your layout, and they always have, they sort of, some people, I really like the one person is saying, start with your important points on the left hand, and then you drill down to the details. So there's some really nice rules that data architects need to learn in terms of helping people structure and lay their diagrams out so that people can read them. And Steve Hoberman also tells you how to read a data model. He says, start with the top left-hand corner and read clockwise. Okay, so, and this is how you should be laying your model out so that you actually, people read it the way you see the importance of the data entities, the business entities within the system that you've got.
That might be tricky with people who read the opposite way. Arabic.
Yeah, but Ross, remember what has
to those kind of
you always
ways
do.
of orientating.
Yeah, but Ross, this is a practice, and this is a way in which data architects have to define the practice of data modeling. They should agree this is how we achieve diagramming clarity.
Yeah.
It's by business. So each business must define their own way. There is no one size fits all. So we're not saying that you have to do it like this. Steve Hoberman says, here is one way of doing it. It doesn't matter which way you do it. You just got to define and tell people how you're doing it so they read it appropriately.
Yeah. It's just with an international organization, you then got those differing elements, the way that people naturally.
It comes back to practice, right? It comes back to a practice definition. Your knowledge management has to go out of from tacit, what's in your head, to explicit. This is the way we do it. This is the way we lay out our models so that people can read them.
Yeah, I think I mean, what really helped me was that Steve Hoberman's idea of having that little camera settings thing, because that sets the context. It's almost like setting the standards. It's saying this is how you must interpret. So you don't give people too much latitude, in terms of going off and interpreting in different ways.
Sure, that's important. But when you're talking about layouts, then those cameras don't really talk about layouts, but it does talk about getting your focus in the right area and then laying it out nicely. But maybe we should extend his analogy on camera to exactly what you're talking about.
Oh, that's what I was thinking. It might be possible.
Yeah, I would think so. I mean, artistically, and JG may be able to help, is artistically you have a way of taking the photograph so that people's eyes are drawn to the right subject, and you don't, I mean, I see it with artists that draw the eyes on the lion or whatever it is. That's where they want you to focus, and everything else falls into place or everything disappears, depending on where you want to be. So that's
okay. Cool, thank you.
okay.
Just
Yes, Paul.
I'll just to maybe a bit of a light bulb share. What you taught me to do on the project when we broke up the data estate into the different areas or categories: behavioral, representative, identity, and reference data.
Yes.
Nicely done in terms of what you're showing here. The vertical drops into the right box.
Yes, correct.
Or the right category.
Yeah, agreed. That's also part of it. Yeah. Amazing. All right. Any further questions before we close down for the evening?
Not a question as such, Howard. It's just like maybe because I'm not an SME in data modeling, but is there like a tool to make things a bit visual? So linking back to your analogy about building house and all of that, like nowadays you can have these nice web interface or whatever the tools are, and you can navigate through the house even before it was built, and therefore you can do your furniture. You can exactly. And another example is like, I use Power BI, for example, a lot. When I build a data flow, I use the data lineage where I would say, I would like to see what is this data source is impacting, which reports does it impact of mine? And straight away, when you have that click, you will have a visual representation of, oh, you're going to hit X and Y and Z. My question is there a similar tool to make both the development life easier and the stakeholder life easier?
Yes. So there's actually something nice, Hisham. You might like it a lot, and it's something called concept mapping or concept maps. And people in some cases are actually using graph databases to map and understand the data that they have and put yourself on any one concept and see what the relationships are. And it's this whole thing of dynamically working with a concept map that you have, and then also with a graph database. And then you can use the graph database to help you, in some cases, apply normalization. So there's a lot of nice work happening in that area on concept mapping to be able to map out the concepts that you have within your business and look at the relationships. Graph databases are good, and I saw a really nice presentation, and I'll see if I can find it, where people are using graph technology. They would click on a node and then it would reorganize the other related nodes to it and just highlight those nodes. Okay, so you're not seeing everything going around all over the place, but one node at a time, and you can see who are the related nodes and how they relate to each other.
Excellent, excellent. Yeah, I think that exactly answered my question. So thanks for sharing that. Thank you.
I'll send you a paper on concept mapping, modeling. I really like it. It's a nice way of visually interacting with the data so that you can build the model from the data. And the one challenge was for me was the case of saying, well, how well are we listening to the data if we're not getting the data to show us how to do the data models?
Agree.
Yeah, but I always like these differences of top-down or forward engineering. The business knows exactly what it wants, or reverse engineering, the business is not sure. Now let's use some of the data to tell the story. But I think you need to be constantly looking at both to say, well, what have we learned that we didn't know? What new information has come about, and how do these things relate to each other? Yes, Ross.
Yeah, so last one. So you could also use that for your business glossary, right? Walking through the business glossary.
Yeah, no, Ross, Mark Atkins has a really nice tool that when you write your business definitions, each statement relates to another term, and that becomes your nodes and links in the graph database. And he visualizes it as a graph database. Very powerful.
Yeah.
Very powerful. That's when your glossary comes alive and people can argue about it and have discussions and things like that.
Well, just a question. Would like the normal tools in the market, like Informatica, Calibra, those type of tool, would they have a similar way to visualize? I would assume yes, right? Or not. I'm not quite sure.
I don't think so. They tend to be standardized data modeling tools like Idera and Power Designer and things like that. But what I have seen is these new ideas of using data to model data and concept maps. They start at a different place, at a different level. But I'll share with you work that Marco Woburn has done in terms of fact modeling. And Hisham, he actually takes and he interviews the business, and they describe all the facts in the business, and he associates the facts with the entities and the relationships. So when you want to look at something, you drill down and you see the business statements that gave him those concepts and relationships. So he's also got a nice way of displaying it, but yes, Grafana as well. That's what Gaucher is talking about. But I haven't really seen them in Informatica. They tend to be standardized data modeling tools, but not the fancy ones that we're talking about now.
Yeah. Okay. Thank you very much.
Okay. Olowa, I'm hoping I forgot how to say your name. Sorry. Olowa Busayo.
Yes, thank
Sorry.
you. Yeah, you tried. So that's just the name, Oluwabusaya.
Thank you.
So my question is, I've been trying to figure things out here from my head. So if I want to start now, like I want to come up with the model of the entire data landscape in where I am. So I want to start from the subject area. So
Yes.
you know that concept of subject area in itself, it's how do I interpret what a subject area
Okay.
is?
Okay.
Then
Fantastic. So
if I now want to break it down further, to what granularity so that it's not too broad, you know, for me to,
yes.
yes, that's my question.
Okay. So we actually have a lovely way of doing it. And I'm going to try to load up something very quickly. And we link this to our business capability, our business architecture. So if you don't have a subject area, how do we get a subject area very quickly? And we look to the business capability model that we work with. And I'm going to do it very quickly and just show it to you quickly, and then maybe we can have an offline discussion on that. So I'm going to present here quickly to be able to say, here is a data landscape, an example of a data landscape with the different value chains. That's the high level model, but that's the end product that you're looking for. This is the business architecture, BizBock, in terms of what the business architect should be giving you. Now, you don't always have it, and there's another challenge where you've got to go and find it, but let's ignore that for right now. Here is the hierarchy of business artifacts, architecture artifacts. First of all, who are your stakeholders? How do you deliver value? And what capabilities do you need to deliver value? And then we go from there, i.e. the value stream, and then we drill down into the capability map. And now we start looking at the nouns on this capability map, and we start building our subject area model. So here we have, for example, what you can do is, I've got a client, I've got an event, I've got a quote, a proposal, accounts receivable, and we can then build that model from that data area. Here you can see the model coming up here, and that's the process. But I think I'll need to spend a little bit more time with you showing you how you can do it, but you need this technique. And that's what Paul was saying earlier on when we had to go into an organization that didn't have a business architecture. We had to build this thing reverse, backwards and forwards and get it back and going. But there's a nice way to link this to your business architecture and get these concepts, subject areas from your business architecture.
Right. Thank you. Thank you.
Okay, pleasure. So we do that in the business architecture course where we take you through this, but we can also have a session. I think we may have done it. Paul does it very well now. He's had a few engagements, and he can also help you then.
Thank you.
All righty. Okay. Any other questions? All right. Fantastic. All right, everyone. Have a wonderful evening and have a fantastic Ramadan for those who are starting. Hope you have a wonderful time and a very special month. Ramadan Mubarak, as they say.
Ramadan
Cheers,
Mubarak,
everybody.
Howard. Yeah, thank you. Cheers all. Bye.
Cheers, everybody.
Bye.
Thank you.
Thanks, everyone. Thank you. Thanks, Howard.
Okay, man.